Okay, hope you're doing good today. Hope all is well with you. Today we're going to be talking about the importance of the remainder and the factor theorems. The question that we should be able to answer by the end of the class says, why are the remainder theorem and factor theorem important for polynomial functions? So I'm going to walk you through kind of like three different sections, and then we'll tie it all together and figure out why the remainder and factor theorem are so important for polynomials. Now, on this page, it's going to say something like a website or something like that. Don't worry about that. I printed out a piece of paper here, and I'll walk you through all that good stuff. So let's start with part 1. Let f of x equals 2x to the third plus 3x squared minus 14x minus 15. Number 1, use synthetic division to divide the following polynomial by x plus 1. Note that a in this example is a negative number. All that means is a is the number that goes in the box. We already know how to do synthetic division. Take the opposite of this, put it in a box. So this is x plus 1. Negative 1 is going to go in our box off to the side. We're going to line up our coefficients. 2, 3, negative 14, negative 15. Draw a line. First number always comes down. So first number is 2. Multiply, add, multiply, add. 2 times negative 1. 1 times negative 1. Add those together. Multiply, and I got 0. So that is, this is part 1, and this is number 1 from part 1. We write our answer out. I got 2x squared plus x minus 15. All right, that was easy peasy. Number 2, now factor the solution from above. So this is what we now have. So we're going to have to go through and do the 4-step method for this one. You know you do the 4-step method when this number here is something other than the number 1. If it was just number 1, we would factor like normal, but this one has something else in it, so we need to go through and do the 4-step method. So step 1. You multiply the first and the last number, and this should be in your foldable on factoring. So you multiply the first and the last number. That gives me x squared plus x minus 30. Step 2, factor like normal. Now this is with the parentheses, you fill in your x's, all that good stuff. So you factor like normal. 2 numbers that multiply to give me negative 30, add to give me 1. Those 2 numbers are negative 5. And positive 6. Step 3, divide by the first number in the problem. So the first number in this problem is 2. That's my leading coefficient that I'm circling right here. So I need to divide by 2. Divide by 2. So I'm dividing each of my numbers by 2. I got a fraction here. Nothing wrong with fractions. And 6 divided by 2 is 3. And the last step, we get rid of fractions because you can't have a fraction if you're factoring. So I need to multiply this by the denominator. The denominator is 2. So we're going to multiply just this part by 2. So that is going to give us 2x minus 5 times x plus 3. So let's recap this step here. Number 2 says, now factor the solution from the problem above. So we took 2x squared plus x minus 15, and we're factoring it. So we couldn't just do the parentheses and fill in because I have a different coefficient here. So we were looking for, we were not looking for 2 numbers that multiply to give me this, add to give me this. We had to go through the 4-step method. So now when I factor 2x squared plus x minus 15, it factors into 2x minus 5 and x plus 3. All right, number 3. Now list the 3 factors of 2x to the third plus 3x squared minus 14x minus 15. I know there's 3 factors, 3 solutions, 3 roots, 3 zeros, because that's my highest exponent here. So my highest exponent is 3. So I'm looking for 3 factors. So I just need to be able to look up here and identify what my 3 factors are. Well, I know we just found 2 of them. They're right here. So one thing, we just found 2x minus 5. And we just found x plus 3. Now, where is that third factor? I can look up here. It gave it to us in the problem. So they gave us this third factor of x plus 1. So it says list out all 3 factors. That's one factor. That's the second factor, and that's the third factor. They gave us a factor, little did we know, but they did give us a factor because I got a remainder of 0. And then we use that factor to break it down, and then we have all 3 factors. And number 4, it says use the factors. Use the factors to find the zeros of f of x. Hint, use the zero product property. And the zero product property says you set the factors equal to 0. So I'm going to take these 3 factors and I'm going to set it equal to 0. And you don't need parentheses. 2x minus 5 equals 0. X plus 3 equals 0. And x plus 1 equals 0. So I took each of these factors and I set them equal to 0 like we did when we first were doing the quadratics. Now I'm going to solve each one. Add 5, divide by 2. I got 5 halves. Subtract 3 from both sides. I got negative 3. And subtract 1 from both sides. I got negative 1. So these are the zeros of the function that we started with. So let's see if I can put all this together. There we go. So we started with this problem over here. Let me put a star by it. Okay. We started with 2x to the third. Okay. We started with 2x to the third plus 3x squared minus 14x minus 15. That's what we started with. They gave us a factor. We broke it down. We factored it, and we found the 3 factors. Now, we don't typically factor stuff to the third power, so this kind of helped us break it down. And then we found all 3 factors. This is the factor theorem. So the factor theorem is all of this right here. It tells us if I give you a factor, you can break the polynomial all the way down into smaller pieces. It also gives us a few other things. It also gives us some ordered pairs. Like if I were to go graph this, it would give us some ordered pairs. And I'm going to write those out in red. Since these are the zeros of my functions, a 0 or a root is where it crosses the x-axis. So these actually give us ordered pairs. So this one, so I'm writing this out in red. This one gives me 5 halves 0. That's one ordered pair. If I were to graph it, it would cross at 5 halves 0. If I were to graph this, it would cross at negative 3, 0. If I were to graph this, it would cross at negative 1, 0. So this actually gives us 3 ordered pairs that if I were to graph the polynomial at the very top of the problem, which is rewritten right here. So this is the polynomial we started with. If I were to graph this, it would cross at these 3 spots because these 3 are the roots. They're the solutions. They are the x-intercepts of my polynomial function. So this is the factor theorem. And it also gives us stuff in factored form. So 5 halves in factored form is 2x minus 5. Negative 3 in factored form is x plus 3. And negative 1 in factored form is x plus 1. So if they said a polynomial crosses the x-axis at negative 7. If you put that in factored form, it'd be x plus 7. So if they said the polynomial crosses at 5, put that in factored form, you get negative 5. So you take the opposite because of the zero product property, and it turns into the opposite when you're solving the equations. So this is part 1. This is the factor theorem. This gives us factored forms. It gives us ordered pairs. This is the first part of our little mini investigation today.